In our first part of this lesson, in the first video there, we found out that rhombuses are parallelograms with congruent sides, all sides congruent. That is the ugliest rhombus I've ever drawn. There we go. And we found out that rectangles have all right angles. They're all congruent angles. They're still parallelograms, but they're all right angles. Okay, so now we're just going to do a couple problems real quickly here. We're going to see what happens or how we can identify these. Okay, so what we're going to do to identify these is we're going to graph them, and then we're going to find some slopes and lengths and decide what kind of polygon they are. So first thing we're going to do is we're going to graph this. So I label all my axes here, and I plot my points like that. There they are, and we should label those guys. So we have A, we have B, C, and D. And now we'll connect them to make a quadrilateral. So now we got to find out what type of quadrilateral it is. We're going to find some slopes and lengths. So first thing we're going to do is we're going to find the slopes. Remember, slope is rise over run, all right? So AB and BC, and let's do it like this. So slope is rise over run. So here we have AB, we're going up a ways. How far are we going up there? Looks like we're going up 8 and over 2. Okay, so a rise of 8 and a run of 2. And then if we count the rise and the run here, that's also going up 2 and over 8. From B to C, we're going down, down 8 and over 2. Count it carefully. Looks like it is 8. Don't just assume it is. And then we're going 2 and 8. So a bunch of 2 and 8s, all right? And so the slopes, let's get these right. Remember that going up to the right is positive slope. Notice all these blue lines are going up to the right, so they're all going to be a positive slope, okay? So here, our slope for AB. AB is right here. We're going up 2 over 8, okay? So that's 2 over 8. That simplifies to 1/4. There is your slope. Slope is a fraction, okay? And then BC, this guy from BC, don't worry about going from B to C. It's just that's the line, okay? We can think of it going from C to B. Okay, we're going up 8 and over 2. So this has a rise of 8 and a run of 2. Since it's going up to the right, it's going to be positive, all right? And so that is 4, okay? All right. And then how about CD? Well, look at the rise and the run there. CD is this line. Again, don't worry about, even though I named this CD, you know, it's going to the right. It's going up 2 over 8. 2 and 8. So it's going up 2 over 8. So the slope is 2/8, which is 1/4. Okay. And then DA, we see that DA is going up 8 over 2. Okay. So don't get caught up in the way that we named it, the order we named it, okay? They're all lines. They're all going up to the right, so they're all positive. And there's our slopes. We notice opposite slopes are the same. So that means it's a parallelogram, all right? So we know that it's a parallelogram, okay? Now, what about the lengths of those sides? Well, you can probably see this pretty quickly already, but we need to find the lengths. And so we're going to use the Pythagorean Theorem. See this right triangle? We have 2 squared plus 8 squared, and we don't know what this is. Maybe we'll call it little c. So 2 squared plus 8 squared equals c squared. Use your Pythagorean Theorem here. And 8 squared is 64, and this is 68. And so we want to find the exact length. The exact length is the square root of 68. Okay? And so that's the exact length. Now, notice all of these make right triangles. 8 and 2, 8 and 2, 8 and 2. They're all going to be the Pythagorean Theorem like this. So we don't need to write it 4 times. I think we can convince ourselves that they're all the same. Okay? Square root of 68. So lengths are all the square root of 68. And then so it is a rhombus. Notice these are not negative reciprocals. So perpendicular lines have to be negative reciprocal slopes. So they're not perpendicular. So it's not a rectangle. So it can't be a square. So the best it is a rhombus. And we showed that, we proved it by showing that all sides are congruent. Okay? We could have also shown it by looking at the slopes of the diagonals. Let me show you that one real quickly. So if we want to look at the diagonals, if we want to look at the slopes of these guys, let's do that here. If we look at AC, the slope of AC going right through here is, I'll let you count that, but it's going down 6 and over 6, which is -1, all right? So we're going down 6 over 6, that's -1. And from B to D here, BD, or from D to B, remember, the order doesn't matter. Okay, but this diagonal right there, if you count that guy, it's going up 10, right 10. So the slope is 10 over 10, that's 1. Now it's a little hard to see, but these guys are opposite reciprocals. If we call this 1 over 1, we can see it maybe a little better. Okay, they're negative, one's positive, one's negative, and they're flipped, so they're opposite reciprocals. So that means they're perpendicular, and we said that a rhombus has perpendicular diagonals. So that also verifies that this is a rhombus. That was kind of an extra, all right? And then how about this one? Let's go ahead and do the same thing. Let's plot the points and decide if it's a rectangle, square, or rhombus. So we'll plot the points. We should always label our axes like that. Now we'll plot the points here. So we got our points, P, Q, R, S there. Now let's get some lines on these things here. Okay, and there's our shape. And stop and look at it. Turn your head, turn the paper a little bit if needed there. And we should see that kind of looks like a square. All right, and so let's see here. Let's find out if it is a square. Let's do what we just did in our last problem. Let's find the slopes, and then we'll find the lengths, and we'll decide what kind of shape it is. So let's find the slopes of all the sides. Remember, slope is rise over run. So we'll get the rise and the run for each of these. You can draw on these little rise and runs. We're going up 2 over 5. 2, 5. I find it helps quite a few people. Helps me sometimes there. Okay. Okay, so looks like we're traveling in 5s and 2s if you count that carefully. All right, we're going in 5s and 2s. So let's find the slope of each one separately. So we got the slope of each of these. PQ, it's going up to the right. So it's going up 2 over 5. Now we've got to be careful here. QR is going down to the right. This is a negative slope. We're going down 5, right 2. So it's down 5, right 2. Then we have SR. This is going up to the right. We're going up 2, right 5, 2/5. Then we have PS. PS is going down to the right. We're going down 5, right 2. Down to the right is a negative slope, so -5 over 2. Okay, so there's our slopes there. A lot going on here. And if we look carefully, we see that opposite ones are congruent. That's great. That means it's a parallelogram. So we know that this is a parallelogram. All right. There you have it in gray. All right, so it's a parallelogram. Well, we also know that these sides that are next to each other, the consecutive sides, have opposite reciprocal slopes. Notice that we've got a negative slope and a positive slope, and the fractions are flipped. That means it's also a rectangle. Okay, so this is also a rectangle. Okay. So we know it's a rectangle. We know it's a parallelogram. Now, we know that we think it's a special rectangle. I think it's a square, and it's kind of obvious, but we can prove that to show that all sides are congruent. So we can go 2 squared plus 5 squared equals, going to find this little length, let's call it c. C squared. Use your Pythagorean theorem carefully. 5 squared is 25. Add, make sure you're working down the page. Don't forget that c squared, because that's going to tell you the last thing we got to do is we got to square root it. So we see that all sides are the square root of 29. And they're all the square root of 29 because they're all traveling in 2s and 5s. It's all about these right triangles, okay? So we've got rectangle. All sides are congruent, so it's a rhombus. And since it's a rectangle and a rhombus, that means it's a square. It's all of these. If it's a square, it's everything, all right? So we proved that it's a parallelogram, rectangle, rhombus, and square by showing the slopes and the lengths. We could have also checked the diagonals. If we check the diagonals here, these diagonals will have lengths that are congruent and they're perpendicular. Let's see real quickly. PR has a slope of -3/7, and QS has a slope of 7/3. And so notice those are negative reciprocals. So these are perpendicular. Since they're perpendicular, it's got to be a rhombus because diagonals of a rhombus are perpendicular. Notice they're also congruent. 3 squared plus 7 squared equals c squared. And this comes out to be 58. And if we square root that, they're 58. So they're both the square root of 58. That means the diagonals are congruent, which means it's a rectangle. All right? Perpendicular diagonals means it's a rhombus. And congruent diagonals means it's a rectangle. So it's a rectangle and it's a rhombus. That has to be a square, okay? So we can show that. So all kinds of ways to show that it's a parallelogram, rectangle, rhombus, and a square, all right? So choose your favorite way and prove that these things are true. All right, go for it.